So I want to wish everyone a good evening. We know that your time is valuable and that out of your busy day, you're choosing to spend this time with us. So we thank you and thank you for your patience as we get started here. All right, it's 6:02. So we'll go ahead and move to the next slide and get started. So I want to wish everyone a warm welcome to the community meeting for the former Singer Friden Site, also known as the Sandpiper Townhome complex. So we definitely want to thank you again. I cannot thank you enough for taking the time out of your schedule to join us. Allow me to introduce myself. My name is James Gambrell. I'm your public participation specialist with the Department of Toxic Substances Control, DTSC for short. And I work out of the Office of Environmental Equity. I know all these different offices and departments, but my role as a public participation specialist is to send out the public notices, the community updates, which most of you probably received in the mail or via email, and also to make sure if there are any questions that I help you find the correct person to answer those questions or to get that information, or anything else I can do to assist the community. And it's my pleasure to work with the community. So with this meeting, we're hoping to be as interactive as possible. So we'll stop periodically during the presentation to see if there are any questions from the community and to answer those as best we can. And if we can't answer those today, we will definitely get back to you and make note of those questions. On the next slide, I'll give some instructions on how to ask questions during the pauses in the meeting. So on the screen, as you can see, during tonight's meeting, questions can be asked in one of two ways. Verbally, by raising your hand, by clicking the icon there, or two, by typing in your question via the Q&A option. So if you raise your hand, you'll have the opportunity to ask your question live, unmute and ask your question. Or if you type your question in the Q&A option, I will read your question out loud and we'll get an answer to that question. If you're joining us using your computer at home, you'll see the raise hand and Q&A icons in the toolbar at the bottom of the screen. Now you may need to hover your mouse at the bottom, move your pointer at the bottom of the screen for the controls to appear. Alternatively, you can use your keyboard shortcut, which is Alt-Y, and that will also raise your hand. If you're using the Zoom app on your smartphone, the icons will be in the toolbar as well. You may need to click on the More button if your smaller screen does not show those icons. And if anyone's dialing in by phone, you can press *9 to raise your hand, and then when called upon, *6 to unmute. I'll call upon you using the last 4 digits of your phone number to identify the caller. I'll repeat these instructions again later in the presentation. Next slide, please. With the instructions out of the way, allow me to introduce you to someone who has done a lot of work on behalf of the Singer Friden Project with passion that is absolutely inspirational. Your project manager, Dr. Moises Carvalho, or simply Mokes. I now turn it over to Mokes.
Well, thank you. Thank you for the introduction. And I also like to thank you all the Sandpiper community members that has joined us to this virtual community meeting, which we're going to update the most recent information that we have collected between 2021 and 2021 and 2022, and some historical data that's relevant to our discussion. Next slide, please. So as a start point, we at the department, we always like to share our mission, which is very important to us, and which it is to protect California people, the communities, and the environment from toxic substance, to enhance the economic vitality by restoring contaminated land, and to compel manufacturers to make safer consumer products. And I also like to restate in another way is also that the department, it is looking for funds and trying to promote investigation and cleaning up of the sites or properties that has been disproportionately being impacted by contamination. And we are acquiring funds to complete site authorizations and implement a remedy to improve the quality of those communities. So, next slide, please. And for this presentation, we're planning to talk about briefly about the site background, some key concepts, mentioning about the groundwater remediation performance, the recent sampling results, the upcoming environmental assessment work that we're planning to conduct in 2023, the remaining of 2023, and the mitigation measures that we have implemented at the Sandpiper property. Next slide, please. This slide is good. As a site background, as you can see there is a radio photograph of the Singer Friden facility that was taken in 1957. Based on our historical review of data that was available, the known operations from 1936 to 1976 at the Singer Friden facility use a variety of chemicals, including two chemicals that I have mentioned in several times throughout communications, which is a trichloroethene, which we use an acronym as TCE, and tetrachloroethene, which we use an acronym as PCE. These chemicals were used as clean solvents for the fabrication of electronic calculators, circuit boards, computers, cash registers, and sewing machines. Next slide, please. So this slide here is the intent is to show the most relevant activities or events throughout 1936 to 2023. So I split in two slides. The first one is going to be talking about from 1936 to 2001. So as I mentioned in the previous slide, the Singer Friden manufacturing operated at the property from 1936 to 1977. In 1978, the Citation Homes bought the property and developed into 190 single-family. And in 1980, after the site was developed, the federal law known as CERCLA, or which is standard for the Comprehensive Environmental Response Compensation Liability Act, which is also known as the Federal Superfund Act, it was promulgated. So what that entails, why it's so relevant that I'm mentioning right now, is because the site, the property, was developed prior to the environmental laws. It was promulgated. So therefore, at that time, they didn't have no regulatory agency able to assess if the property was suitable at that time to be developed as a residential area. So because of that, the site was developed with the contamination still in place. In 1989, the department learned about the impacts that has happened at the Sandpiper property. And at that time, we started investigating who was the responsible parties for the contamination. It took some time for us to collect all the information. After that, we secured funds and we conduct investigation of the property. We determined what kind of contamination was present, what risk was entailed at that time based on that understanding. And in 2001, we implement a remedy for the groundwater. And that was that's when the remedy was constructed. I would like to stop right here and to know if there is any question, if any topics that I discussed.
I'm going to take a look at the question and answer to see if anyone has any question and answers typed in. I'm going to look for any hands that are raised. And at this time, I do not see any hand raised. Does anyone have a question or a comment they would like to make, please raise your hand or type your question into the Q&A option. Okay, I think we can move forward.
Okay, so the next slide, please. So the next slide is showing from exactly where I stopped, 2001 to 2023. So from 2001, we started conducting the groundwater remedy, but at that time, starting in 2007, we started looking at alternative options to improve the groundwater performance. And we conduct some in situ pilot studies starting in 2007, and we continue into 2012. And it was several different types of remedy that we test, and those remedies that we test, it shows that would be able to be implemented at the property. In 2014, we initiated indoor air sampling, and based on the results, we start to installing some mitigation measures for some residents that we noticed that the indoor was impacted. In 2015, we shut down the groundwater treatment system because it was not removing enough contamination from the groundwater. I'm going to touch upon more details about that. In 2018, we did continuous conducting more environmental assessment to determine the lateral distribution of the soil gas contamination. And we conduct also between 2018 and 2023, we collect sewer vapors from the sewer lines. We continue conducting indoor sampling until now in 2023. In 2023, now in the second semester, we are also proposing some environmental testing to provide us a better tools to provide a more suitable soil vapor remedy to the site. Next slide, please. For the key concepts, we're going to be talking, we're going to be talking about all those concepts, which is the chemicals of potential concern. I will discuss briefly about the human health risk screening levels, the effects of the local geology, the VOC migration routes, so VOC stands for volatile organic compounds, and the vape intrusion. Next slide, please. So the chemicals of potential concern is sometimes you might see this term or terminology in some technical reports or some communication. So that is a list of chemicals that has been selected as may pose health risk. And those are based on risk assessment study on results of samples that has been collected at the site. And we have determined that the chemicals of potential concerns, they are the volatile organic compounds, which stand for VOCs. And what it is a volatile? Per definition. So volatile per definition, it is or volatility, it is the material quality which describes how easy a substance can vaporize. So I'm just going to give a very simple example. If you have a substance such as something that you have typically we see in every single kitchen within the community, which is the Clorox. So the Clorox we keep sealed or we keep closed, but we've opened up, all the liquid that's there eventually is going to vaporize. So we call that a volatile, and because they're organic, so we call organic compound. We call volatile organic compound. On the other hand, just to give an example to contrast, a cooking oil, which is liquid, but when you open up the bottle with the cooking oil, they would not immediately vaporize under normal conditions. So we call that not a volatile organic compounds. In that way, we call it just a liquid. So there is that definition. Next, please. So for the chemicals of potential concerns, the most frequent ones that detects as a VOCs for the different media that we collected, which is we call the samples that we collect, we call environmental media, and we collect 4 different kinds of environmental media, from the groundwater, soil gas, and the indoor air. In the groundwater, we found all this list of chemicals here. I'm just going to go with the simplistic way to say the TCE, PCE, the Cis12-DCE, chloroform vinyl chloride, and 1,2,11-DCE. And in the soil, we see TCE, PCE, soil gas, DCE, PCE, and vinyl chloride, and indoor air, PCE and TCE. I think the main message is that we see several kinds of VOCs in the different medias, but the most prevalent ones are TCE and PCE. Next slide, please. Another topic that I want to touch upon, it is the human health risk screening levels. We're always referring to the DTSC human health screening levels, the DTSC toxicity screening levels, and the risk screening range. Next slide, please. For the DTSC human health screening levels, what that stands for is the human screening levels are the amounts of chemicals that are safe to people to be exposed to. And we come to assumption for how long is that exposure. And that exposure, it's very conservative. So that means it's very protected. In our assumptions to derive the screening levels, we assume that a person may or someone may be exposed to that amount of chemical for 24 hours per day. So basically the entire day. And 350 days per year. So within 365, he will be exposed to it 24 hours, 350 days, and through a lifetime exposure, he will be exposed 26 out of 70 years of lifetime. So it's very conservative. And also, the state of California has set these human health screening levels for many chemicals based on scientific studies. So it means that we derive those numbers based on laboratory studies, based on a scientific methodology, and we extrapolate that to assess how would be the risk to human. And also, it's very important to understand that these screening levels are very low, and they're set up in a lower level to be protected from people to getting sick over a long time. It does not mean that if you're exposed to a concentration at the screening levels that we set up as protected, that you will develop a related disease right away. That's this number that we set up is very protective, and it's very low to prevent that onset of disease might happen. Next slide, please.
We do have a question which may be related to what you're speaking to.
Oh, I'll be happy to address. Can you? Sure, go ahead.
This question comes from an anonymous participant, and I'll read it now. The initial letters notifying the residents of the presence of VOCs only mentioned that the levels were higher than the governmental standards, but did not list the exact levels. Where can that information be found, or can you provide that now?
Okay, let's see. The way we communicate to the community either is because we collect indoor samples from their house. In that case, we send the letters directly to the resident. We call a cover letter, which we state the concentrations that was measured, and we compare to the screening levels. And we always has an open communication with those residents to be able to address those questions. For the soil gas data, they have those results are documented in reports, and they are public available on our EnviroStore, which are our database. And at the end of this presentation, we're going to share the link to the EnviroStore. And also in every communication that we send to the community, we, if it is a reference to report, we always make sure that's the link it is including that communication. There is any other follow-up?
That was the only question, and I did put the EnviroStore database link in the chat to everyone.
Okay, so for the now talking about this slide, which is the DTSC toxicity screening levels, which are different numbers. So we have initially the screening level, which is set up for long term exposure, and then we have the toxicity screening levels, which they are based on the risk to other health effects such as health damage, or birth defects, and they are set at concentrations that do not harm human health over lifetime exposure. What that means, so I'm just going to give an example. If there is a screening level for toxicity set up at 2.0, that means if someone exposed to up to 1.9999, so below 2.0, it's set up in a way that's unlikely that that person or someone will develop organ damage or birth defects exposed to that chemical. If it is exposed at a concentration higher than that, it does not mean that the person will develop a organ damage or birth defects. Just to give an example, that means that there will be a more possibility, more likely to develop, and that how it is determined or not, it's based on the individual health conditions, how long they've been exposed, and different conditions that's associated. So it's very specific, and typically the department contact that individual or the community that they expose to that concentration that are above this toxicity to address in a more specific way. For the risk screening range is a tool that helps us to estimate if that's something better, it would happen to our health because of exposure to that chemical. So sometimes we indicate when we have our screening levels, you say that's 4.5 times 10 to minus 6. And in some communication, we say this is a risk screening range. And the 10 to minus 6, it is a very low number. That implies that the lower the number, less likely that something happened. Just give an example. If we say there is a risk range to 10 to minus 6, that means that there is a risk of 1 in a million chance of someone might get sick to expose to that chemical. So it's a very unlikely. So that means for the entire population that we are considering for 1,000 individuals, there is a possibility that only one might develop that risk. That's what that means. So it's a very low number, very unlikely that might happen. And now, yeah, so that's, I think, the last slide. And now I'll also like to stop here to know if there is any additional question regarding to the human health risk screen levels.
We'll take a moment now to take a look and see if there are any raised hands. And at this point, I do not see any raised hands. And I will check the Q&A. Excuse me. And I do not see any Q&A at this time. Please continue.
Thank you. I would like to touch upon about the effects of the local geology. So what I mean for the local geology. So the local geology, it is our understanding about the local geology is derived by the soil samples that we have collected when we drill to install wells or to collect soil samples. So we investigate, we identify how the soil is related to another soil samples, and then we try to assess what would be the sedimentation model or the local geology for that particular soil. For the soils at Sandpiper, previous slide, please. Yeah. So for the soils in Sandpipers, what we identified that the soils, the local geology there follow a floodplain sedimentation model. So if you look at this first schematic here, you see that there is a river that we call a meander river. So for the areas that has high velocity, there will be deposits of sand soils. And the areas that has low velocity, you have deposits of more fine material. When you look at in a more lateral disposition, you're going to see that this type of sedimented deposition, it is what we call alluvial fan. So you have the Meander River, it flows in this one direction, and over time it starts to migrate in another direction. And over time, it would have an alluvial fan shape. And if you look here down on this right-hand side figure, you're going to see a cross section. This cross section shows that you have layers of more fine material and layers of more coarse material. And that's what we're seeing at the Sandpiper property. We see layers of fine materials and lands of more coarse material. Next slide, please. So this slide, it is a more block diagram that I took from a handbook, but the idea is to show, if you see on the first block model on the left-hand side, and you see here in a more reddish color, that's is trying to represent if you have a groundwater plume, which means a groundwater that has contamination on it in a higher concentration. So this plume would be we have a tendency initially to migrate through the more porous material because it is more transmissible. But now, looking at the second portion of the slide, you see that I have here a halo here, and that's for the fine material that surround this more transmissible material. And this is very important because of the type of contamination, the contaminants that we see at the property, they have a tendency to sorb to the more fine material. Sorption is a technical term to indicate that the chemical has a tendency to stick. In this case, they stick more to the soil, to the groundwater. But later, when the groundwater it's either cleaned up or the contamination is moved away, the material that was sorbed in a fine material, what we have a terminology we call back diffusion. So they migrate back to the groundwater, so the contamination persists. This is very important to understand why it's taking so long to clean up the groundwater. And the main factors are because of the type of contamination and the type of the local geology. Next slide, please. So this is a schematic figure that shows what we call the VOC migration routes. So it shows that if you have we call a release of a source at the ground, the type of contamination that was released at the property during the time that was under operation, typically they're more dense than the water. So it means they have a tendency to migrate downwards, not even at the water table, but also go below the water table. And it shows here how the contamination can migrate downwards. It can migrate laterally, depends on if it has a more porous material, like a sand soil lens. It shows here that portion of the contamination can change to a different stage, so it can volatilize, and it can go into the ambient air, or it can go downwards into the groundwater. It can migrate along the groundwater. It can go as a volatilize from the groundwater and also migrate into the ambient air. And all this migration into the ambient air and going inside residents, which are where there are the receptors, we call a vapor intrusion. And I'm going to provide more detail about vapor intrusion in the next slide. So this figure, which is also included in part of our fact sheets, show the vape intrusion. And if you see here on the small details here, it shows like in a zoom for soil particles. Here you see that's the soil particle, the void space of the soil. It would consist of pockets of air and vapor and water. So this vapor, they can migrate into indoor space from cracks, caps, and also can go through sewer lines into their house, and also can migrate from the dissolved contamination as a vapor and go into the groundwater. I would like to stop here at this point to know if there is any question for this topic.
Thank you for that information, Mogs. If you would like to ask a question, please type into the Q&A your question. It looks like we had a question. Someone had said that they needed to leave the meeting, but they would like a link to the recording. So once the recording is uploaded, we will provide a link. I'll try and get that to the Homeowner Association to mail out to everyone if they would like to watch the video in their own time and in their own pace. But please, if there is any questions, we would love to interact and answer any questions you might have. Wonderful. We have a couple of questions here. Question number one, this comes from Gail Randall. Will there be further testing done here at Sandpiper?
We are proposing additional testing for soil gas. We are proposing a pilot study, and we are proposing continuous indoor sampling. We're going to be discussing those investigations, or what we call environmental assessment, in some slides later. But yes, we will. We are proposing.
Thank you, Mogs. And I have another question from Lisa Kelly. What level of contamination is contained currently in our drinking water?
Well, the drinking water, it is regulated from other agencies, and I do not know what, because the drinking water, it is not from the groundwater at the Sandpiper. I only can speak what we have measured in the groundwater. Unfortunately, I do not know the drinking water, but they are supposed to meet some standards that whichever water is served to the community, they're not supposed to be with contamination or contaminants above a concentration that might pose health risk.
Thank you, Mogs. And I will make a note here because the question is quite simply, is our water safe to drink? And so what I'll do is I will meet with Mogs to see if we can get a resource to better answer that question. It's a very important question. Absolutely. So after the meeting, I will meet with Mogs and we'll see if we get a better resource to give you an answer to that very important question.
Yeah, it's a very important question, but I want to be very clear here that the groundwater from the property, it's not suitable for drinking. We have published information to the Leandro community in the 90s, recommending that the groundwater is not supposed to be used for human consumption. And that's also has been informed for the Dundee Homeowner Association that the groundwater that it is in a Sandpiper, it is tailored to human consumption. But for the groundwater that we consume from the tap, they're supposed to be protective. And as James has indicated, we will consult the local agency and we'll double check and we'll provide that information to you.
And that goes hand in hand with the question about growing food in their gardens in the backyard and that sort of thing. Is that right, Mogs?
For growing food from the backyard, that question has been placed to us before in a public meeting, and our site toxicologist has indicated that for the fruits trees, if you pick a fruit from a tree that grows there, it's very unlikely that they would have the VOCs that we are concerned in a level that might pose health risk. If you grow vegetables in your garden, the department recommends that only the top soil can be used. Any soil that's what we call the native soil, it's not recommended to be used for human consumption. And the reason why we mentioned that, because the site was developed without proper characterization, and the information that we have that there is a fill material, which means not native, from 1 to 9 feet below grade. We don't have no more detailed information. So basically, our assumption it is that residents are not supposed to do any excavation that might expose the native soil or the original fill material.
Thank you so much, Mokes. Those are some great questions, and I really appreciate the participation and the back and forth. We're excited to answer any questions you might have. You can also click the raise your hand button if you'd like to answer a question, or continue to type in the question and answer if you have any questions. I'll just wait another moment here to see if there's any more questions. And it doesn't look like we have any at this time, so we can move forward. Thank you, Mokes.
Yeah, so for this slide now, so we talk about the site background, the key concepts. Now I will touch upon the groundwater remediation performance. Because the groundwater remediation performance was conducted from 2001 to 2015, this is just very brief discussion, which is really consistent based on this slide. And what I want to stress is the groundwater remediation system achieved high mass removal at the beginning when we installed within the first years, but after a decade, the mass removal decreased, and that's one of the reasons why we started doing our pilot study in 2007 to see if we could improve the system or have a different remedy system. And because the system was not removing a lot of mass, in 2015, we shut down. So I have 2 boxes that I have put here on the bottom of this slide. On the right-hand side, it is the green box. It shows the VOC estimated mass removal. So how we estimate the mass removal? So basically, that's why we say estimated. So basically, we sample the groundwater and we analyze for the VOCs, and then we calculate the total mass of all the chemicals that analyze as a VOC, and then we estimate how much would be that in mass. So from 2001 to 2015, our number produced an estimation that we have removed 265 pounds. But as you notice there at the bottom of this green box, from 2012 to 2015, so the last 3 years, we only removed 2.3 pounds of mass. So that's only 1% of the total mass. And that's the main reason why we shut down the system, because it was not removing a lot of mass. Another way you can see if the system was efficient or not just based on the mass removal, is to try to see what was the average concentration of the TCE and PCE at that time. What is an average concentration? Basically, it is if you get all the wells that we sample in all different depths, and we add all them up and just average them. So that's the average number. And the second, it is what I like to say is we're using here a unit which it is micrograms per liter, which is a scientific unit based on an international system. And sometimes it can be very complicated, difficult to understand what that meaning, because it's different units. So I'm going to just use as parts per million, which we talk about ppm. So that's unit part per million, just tells us in relation to a concentration. So we are talking that's 21 parts per million of PCE over a standard unit. But regarding that, just thinking as ppm, so without any unit associated. So we had 21 ppm of PCE and 600 ppm of TCE in 2001. And in 2015, we had 7 ppm for PCE and 123 ppm for TCE. So we see it has some reduction of the concentration. It shows that although the groundwater remediation, it was not performed as we initially planned, it was efficient because it was able to remove and also was able to reduce the average concentration. Next slide, please. So for the recent sampling results, I would like to talk first the groundwater monitoring results. And the groundwater monitoring results were resumed in 2018 on a semi-annual basis. DTSC has sampled groundwater from 27 wells. And those are 11 monitoring wells that was part of the initial groundwater remediation system, 7 piezometers, and 9 former extraction points. And that was to monitor groundwater from 4 different depths. We call units underground that contains water, we call aquifer. So you might see some communication that we are monitoring 4 different aquifer zones at Sandpiper. Next slide, please. So this slide here, it is an animation. So for those ones that looking at in a computer screen, you might see that there is some animation. This is a GIF. So the idea that we're using a GIF is just giving a sense of time, how the groundwater plume has changed over the time. So on here on the right-hand side, we have the concentration, what those color means. So 5.0, it is what we call the maximum contaminant level. It is what we set as the maximum concentration to the water be safe to be drinkable. So anything about 5 for TCE means that the water is not suitable for drink water. So here you have 5 to 10, so it's just 1 times higher, and then tied to 15 means that 10 times higher than the level which it is safe to be drinkable, and so on and so forth. I would like just you concentrate on the shape of the plume and where it has the more warm corals. So you see, starting now I'm going to circle back to 2018. You're going to see in 2018 you have more the plume. We call this color as a plume is more spread out, and over time it is more so towards the southwest portion of the property. So that means that the groundwater that was treated and mobilized and contamination that was mobilized during the groundwater remediation system, once we shut down the system, the plume migrating downwards, we saw some back diffusion, means that some contamination has went back to the groundwater. But over time, which is now looking at the data from 2022, most of the groundwater contamination is residing on the center southwest portion of the site. And the department is aware that most of the groundwater contamination is this portion, and we will promoting and we will be advocating that we're going to be implementing some remedies to treat the groundwater in those locations. Next slide, please. This is for the PCE, as when you compare the lateral distribution of the PCE plume compared to the TCE that I show, as you can see, the lateral distribution is smaller. The level of concentrations, it is lower than TCE, but also you may see that in 2022, most of the contamination for PCE that's above the MCL resides also in more in the center and the southwest portion of the site or the property. Next, please. Now, I would like to stop here. Can you go back to the groundwater? Yes, please. To know if there anyone want to have any questions about the groundwater monitor results before I start discussing the data for the soil gas?
Take a moment here to take any of your questions. Again, remember, if you want to type your question into the Q&A and I can read it out loud. Also, you can raise your hand if you'd like to speak and ask your question or even make a comment. And we really do appreciate you being here and listening to our presentation and speaking with us tonight. So thank you for your time. And at this time, I don't see any questions, Smokes.
Okay, so next slide, please. So this slide shows a summary and shows on a table from the soil gas assessment results that we collect from 2019 to 2022, and it shows the maximum VOC concentration. And here it shows that we have a different unit, which is micrograms per cubic meter. And once again, if you just look this number and call ppm, makes easier to understand relatively how it is a concentration. So for the most prevalent compounds are, as I mentioned before, are TCE, PCE, and vinyl chloride. Here we see the highest concentration for the chemical that has the highest concentration measured was PCE and was 49,000 ppm, second by TCE, and then vinyl chloride. And for the vinyl chloride, I would like to stress that only 4 of the 190 samples that we collect that we detect vinyl chloride. And here is how we assess if the soil gas concentrations are higher or not, or screening levels. So this first number here, it is for the human health screening level, and the second number here, it is for the toxicity. For the next slide, please. So for this slide here, it is a way to us to represent how would be the predicted indoor air concentration if we take into account the soil gas that we measured. We test soil gas, as shown here in both figures, at 36 different locations. We found that the most prevalent chemicals are TCE and PCE. To us to be able to derive what we call the predict indoor air, we use the measured soil gas data, and we use a formula we call attenuation factor to predict what would be the air concentration from the soil gas. So basically what we're saying is, we have, just to give an example, in a particular location here, we measure a soil gas concentration. We use this equation, this formula, and predict if it was a house built on top of where we collect the soil gas, what would be the indoor air concentration at that residence. And then with that, we determine if it is necessary or not, or at least recommended to collect indoor air sample to confirm if our predictions are correct or not. So in this case here, for the PCE, as you can see here, there are several locations where we collect soil gas sample that our prediction indicates that the indoor air, if a house was built where we collect the soil gas, would be higher than the screening levels. So just again, I'm going over here what those colors means. So from 0 to 15.3, which is colors blue, means the concentration was below the screening level. From 15.3 to 153.3, which is colored in yellow, means that the screening level, it is 1 to 10 times higher. And for the orange color, it is 10 to 100 times higher than screening level. And red, it is more than 100 times. Another way to say is, for those areas that has a color code more warmer, so it means towards yellow to red means that there is the high possibility that the predict indoor air quality will be impacted by the soil gas. When you compare to the TCE on the right-hand side, you can observe that the TCE is more prevalent only in the center portion of the site. And instead of PCE, it's more widespread. Next, please.
Mokes, I'm going to ask Reverend Angela Brown to unmute so she can ask her question.
My question was about 2 slides ago, and you had the map up, and I was just trying to get a point of reference.
So do you want me to move the 2 slides before?
Yeah, just where is the East 14th gate and where is the Washington Street gate?
And I'm sorry if I didn't have that reference. So for the left-hand side, it is the Washington Avenue gate, and the right-hand side is the East 14.
Thank you.
Welcome. And I do apologize if it did not have that reference straightforward. Thank you for bringing it up.
And we do have another question from Josh Johnson. Will you share the slide deck too at the end? And absolutely, we'll save this as a PDF, and then we will upload it to the Enviro store so that it's available on the database.
And for that, I want to make 2 comments. So for the PDF version of this presentation, you're going to see in some slides, we're going to have some stamps, meaning that those are only was made from this presentation. I have not mentioned before during this presentation, we are still in the process of collecting the data, reviewing the data, and they are be properly documented in a document we call Remediation Investigation Feasibility Study. And that's where all this data is going to be properly assessed, and we will identify the most suitable remedy. We have a very fairly understanding which are the most suitable one, but we have to do a proper and a detailed assessment to be able to defend that our proposed remedy are the most suitable and the most efficient ones.
And we also have a question from Gail Randall. Should any of this information be shared to potential buyers?
Good question. I can refer to a consent agreement that we had with the Dundee Homeowner Association, which I'll be happy to share that documentation, that reference, that indicates that the homeowner doing the property transaction, they're responsible to share that information to any potential owner. So that's not a confidential information. And we will share that reference on our agreement with the Dundee Homeowner Association.
We have a hand up. One moment while I ask Vanessa to unmute and ask her question.
Okay. How are you using these predicted air maps? So you've shown that you've predicted the PCE and TCE. So what do you do with this?
Yeah, so this is a 2 graphics or figures that we have prepared for this presentation to facilitate this discussion and to share to the community why we as a department, we really want to collect indoor air samples from the community, because with the indoor air samples, we empower you, resident, and ourselves to make a better decision to assess if there is a risk or not. This is us using the soil gas data that we collect from the common areas of the property, and we are extrapolating to predict what will be the indoor air for the nearby residents. But the only way we can assure if what would be the indoor air concentration, it is actually sampling the residents. And one of the reasons is that we find out that even when we collect the indoor air sample from 2 residents that share, the wall, we see that sometimes the indoor air concentration might change. And one of the main factors is because of the conditions of the the concrete on-grade slab. We have seen that depends on how long it was the last time that the flooring was renovated. If the crack in the sill, that might cause, and pose different behavior, how the vapor might be able to intrude in the indoor air, and also might, consequently might change the results as far as the indoor air concentration.
Do you have a map that indicates where you're collecting the common area samples?
Well, we have our reports for the soil gas monitoring we did in 2019 and in 2022 does show the map of the location that we collect, and also shows the concentration does measure, but does not show this figure. So that's what I was mentioning before. We are still in the process of assessing these maps and assessing the results, and those are being properly documented in an upcoming report that will be likely ready to us to review and approve in early 2024. That report here will consolidate all the data that has been collected at the property.
Okay, thank you.
Welcome.
Thank you, Vanessa, for those questions and your inquiries. I have another question in the Q&A from CAD's iPhones. I responded to the past 2 letters from DTSC requesting to be included in the in-home monitoring, but I received no follow-up communication from you on either. The first was just prior to the pandemic, so I believe the testing was postponed. However, I did not get a response to your last survey. Secondly, I read that mothers, fetuses in their first trimester were more at risk to these chemicals. Are you aware of this?
Okay, thank you for the question. So let's first for the pandemic part. Yes, in 2019, we collect a list of residents, and I have assembled all the residents, and we collected the email address, and I was under the impression that I have reached out all the residents to be able to contact them and inform them that we are in a voluntary base collecting indoor samples. And also we have sent letters to the community informing them they could contact me directly to enroll themselves to the indoor sampling. Regardless, and I do apologize that if you are not being contacted to be your house to be tested, we are open to any enrollment, and you just need to tell us that you are interested to have your house be tested, and we will send it out to you a authorization form so we can access your property, and then we will collect the indoor samples. So we will coordinate with our contractor. There are some slides that I put here that I will go a little bit more detail about the indoor sampling. The second question, yes, I'm aware, and that's we call the chemical, it is trichloroethene, TCE, and there are 2 numbers that not are related to what I call the toxicity. Though the TC toxicity is higher than the number that I'm going to talk about now. So we have 2 numbers which we call the ARL, which is an accelerated response action level, which is set up at 2 micrograms per cubic meters for TCE, and that when we measure any indoor air that's above 2 micrograms per cubic meter, we'll contact the resident to start to do a more detailed investigation, what would be the source. And if we measure concentration that's above 6 micrograms per cubic meter, that's triggered an emergency response, and we engage with the community or with the residents to find a mitigation measure that will reduce the concentration to a safe level. If a resident, not only at Sandpiper, this is for any we call receptor, that a female that might be pregnant and during the time of exposure within the first 3 months, there is a possibility if that person it is exposed to concentration of TC above 6 micrograms per cubic meter, it might have a possibility that the fetus might develop a heart defect. But thus it is a possibility. But the department has set up the level of 6 micrograms per cubic meter to be able to react and prevent that exposure in a higher concentration that might increase the risk of the birth defect.
Thank you, Mokes.
Welcome.
I'm going to go ahead and put my email address here for anyone that would like to send me an email and let me know if you'd like indoor air testing. We'll go over that further in some slides a little bit later on in the presentation, but I just want to get out there in advance that if there's anyone that is interested in the indoor air sampling at no cost to you, we'll be more than happy to send you the authorization form and get that taken care of. So we'll go over that a little bit more in slides. I think there's like 5 more slides or so until we get to that portion. But thank you for these great questions, and keep the questions coming, because we definitely appreciate you taking the time to interact with us and bring anything to our attention and ask any questions that you might have. Thank you again.
Next slide, please. Thank you, James. So as you might have seen us in 2021 and 2022, we collect sewer vapors from the sewer lines at Sandpiper, and to assess the potential exposure of residents to vape intrusion from the sewer lines, as contaminants may pose health risk. So it is a schematic how we collect the sewer vapor. So we collect from above the ground. We drop it off a tubing about 1 feet above the bottom of the sewer, or the top of the sewer liquid, and we open up the valve of that sewer canister and we collect the soil sample. So, and it's simple process, but because it is, as you see, there is some opening. It is a big opening, so the data is suitable for changes, and I'm going to explain to you better in the next 2 slides. Next slide, please. So these are the data from 2021, and it shows on the left-hand side the PCE measure concentration, and the right-hand side TC concentration. And I color code then, just to facilitate the discussion. We do not have a screening level to compare the measured PCE and TC concentration of sewer vapor. I just color code 2 to 15.3 blue, just to compare to the soil gas screen level, but they are not correlated. And above 15.33, I color code red, just to have a sense what is high concentration, lower concentration. When you compare the 2 figures from 2021, it says slightly behave the same. So we have very similar spots where you detect PCE and TC. And we saw that there is a higher concentration in an area on TC. One thing I want to point out is that typically we don't see PCE and TC in a sewer vapor. So if you see PCE and TC in the sewer vapor, they're either associated with contamination from the ground or from the groundwater, or exposed from household product that might have PC or TC. Next slide, please. So this one is from 2022, and as you can see, the concentration has changed. Now they are more prevalent, not only because we have collected more spots, but also you can see we have higher concentration, and they are more for TC on the more southwest portion on the Washington Boulevard side, Washington Avenue side of this the property. But also I want to point out that the sewer vapor, they are highly dependable on on the time that we sampled, what it is, how it is the residents using the sewer or not. So if there's a lot of discharge at that time, the concentration might change. And so therefore, we cannot really compare the data when we measure from one point to another date, but we can see how it is the lateral distribution, and we can try to correlate that with other media that we collect samples, such as the soil gas or the groundwater. Then we can assess if why we're seeing the PCE and TCE as sewer vapor. Just can you go back? And I'd like to know if anyone has any question about those two slides.
I'm going to look in the question and answer and give some folks a chance to raise their hand if they have any questions or would like to ask their questions directly. And also as a reminder, you can send me an email also afterwards if you have any questions or requests. And at this time, I don't see any questions.
Thank you. So next slide. So this slide is to mention about the subsurface utility line geophysical survey that we conduct at the property. And the reason why we did in 2021 this utility line geophysical survey is because the Dundee Homeowner Association informed us that they don't have an as-built for the underground utility line. And that's very important to us to have that information, because knowing where the subsurface utility line are located will facilitate us where we are supposed to place our soil vapor or soil gas remediation system. And also to make sure that when we do our investigation, we're not going to hit any of the underground utility lines. Next slide, please. So it is just a figure that shows where we have identified the utility lines. I understand that it is not with a very good resolution, this graphic, but the intent is just to show that we have measured and we have now a better understanding where they are aligned, and also that's going to empower us to better design the soil gas remediation system, because the utility corridors can disrupt the flow of our potential select remedy, and I will discuss that later in a few slides. Yeah, so the next slides that I want to talk about, which is what we call the upcoming environmental assessment work. And next slide, please. And those are the three environmental assessments that we're planning to conduct on the remaining of 2023. And once you complete those environmental assessments now in 2023, we will consolidate all the data in what I was mentioned before, the remedial investigation and feasibility study. And that document will facilitate us to amend the current remedial action plan. And what it is a remedial action plan? It is a document that lays out what it is the select remedy and how we will implement the remedy to be protective and reduce the contamination at the property. So the environmental assessment that we're planning to do in 2023, it is the SVE, which stands for Soil Vapor Extraction System Pilot Test. So it will be a pilot test. And we will conduct environmental noise assessment. And we're also proposing a supplemental soil gas assessment. Next slide, please. So this slide shows a schematic of a soil vapor extraction system. And what it is a soil vapor extraction system? It is a fancy name for something that's very simple, in a way that we install perforated wells at some depth, and above ground, we have a vacuum blower, which creates some vacuum. And with that vacuum that's created, they draw the air into the piping, into a above ground treatment system, which the contamination is removed, and then the treated air is released into the air. So it is in a nutshell what is SV pilot study. But next slide, please. And we have select this portion of the area that we are proposing to conduct a pilot test. And as you see here, we are proposing to conduct this pilot test in the Cornwall Way between Dundee and Croydon Court and Croydon Place. And why we select this property, among all the locations that we have at Singer, why we select this location? First is a location we have based on our utility survey. We know that we have a very good space between the utility. It will be wide enough to do our drilling, so we're not going to be blocking any traffic. So residents ingress, egress can continues doing our pilot test. And also because we know this area has high concentration of PCE. So it's important to us to conduct a pilot test in an area that we know that we're going to be collecting meaningful data. And also it's very important that during the time that we will be doing the vapor extraction pilot test, we actually are cleaning up the soil and removing soil gas. So ultimately, we are also being more protective of the community or the residents that live nearby where we are doing the pilot test, because that area is known to have high concentration of PC underground. So if you conduct a pilot test in this area, we'll be more protective than conducting in other areas, and also be safer because we are not going to be blocking any roads. And if there is such like an emergency, so we know that we can continue our pilot studies and we will be posing the minimal disruption to the residents. And associated with the SV pilot test, as we're being informed, and when we talk to the community members, we're very aware about the concern about noise emission, and we know that this type of remedy, which it is a vacuum, which is creating an air displacement, and any technology that they create air displacement, it makes noise. So we are aware that this is a remedy that makes noise, but we were, with this environmental noise assessment we are proposing, we would like to know what is the environmental noise background at the Sandpiper. So here I showed actually picture from the property on the left-hand side. It shows one of the proposed locations where we will place this noise meter to collect the noise background. And on the right-hand side shows how big it is, so it's small. And that will be running for over the weekend and 2 days. And with that, we have the noise background. So we know what is the noise level at the Sandpiper without any activity, any disturbance. During the pilot test, we will also be collecting in real time the data to assess how much it actually noise has added to the background. Next slide, please. So having those information, the background, how much noise will be added, we will do a modeling. This is going to be doing on desktop, so it means at the office. And we're going to be based on the information that we collect, the performance of the soil vapor pilot test. We will assess what kind of blower will be more suitable to get the level of remedy that we like to attain, but at the same time, emitting the noise level that we think is suitable for a residential scenario. Once we have that information, we will run another assessment we call a noise emission point source. So basically, we will find a device that's going to emit the same level of noise that we're estimating that the soil vapor extraction system will emit at the same location that we will be proposing. So it's very important to have that, because having that information, the community will be able to have an assessment, how much will be the background noise if the system will be implemented, and we will do a survey on that. So that will be a very important information to us to tailor the soil vapor extraction system, if it is the remedy to be selected, to have a noise emission to a level that's going to meet the requirements for the Alameda County ordinance, but more so also to meet the local community requirements, because we don't want to create a place system that will create an amount of noise that will be considered unreasonable by the community. Next slide, please. The other supplemental environmental assessment, it is the soil gas assessment. We are proposing additional soil gas assessment, and that will be only on the common areas that's more between the houses, or what I call the breezeway, which is the landscape. We did not have access to those locations because of the size of the rigs, the type of equipment, and we're proposing to collect soil gas sample only at 5 feet, and we are proposing to install in a way that's going to have minimal disturbance to the landscape area. And why we are proposing those locations? The main reason is because based on the indoor air sampling results that we collect, that we obtained on the 2022, we found out that there are some residents that we found elevated concentration of VOCs above the screening levels that we are not able to associate with the current soil gas monitoring network. And we thought that if we have this additional soil gas assessment, we empower ourselves, the department, to propose a remedy that would be more protective to the residents, because we know in a more fine detail where are the highest concentration of PCE and TCE in the soil gas, and also empower the residents to be able to assess if they want to install a mitigation measure to protect them. So for us, it's very important to have this new layer of additional information, because we will be more suitable to provide a more a remedy that will be addressed in a more fine detail the risk. And our district also shows the location that we're proposing to collect a soil gas sample at the property fence line, and we will contact the residents that has indicated there, that because we need to have their agreement that we're going to be accessing the property to collect a soil gas sample in their backyard. And I would like to tell that that will not be a permanent location. We're going there just to collect the samples once, but we believe this information also be very empowered for the residents, because they would know the soil gas concentration in their backyard, so they can also better assess if they have risk or not in their property, and they may decide if they want to collect indoor sample in their property as well. So for the indoor air quality assessment, as I have indicated previously, the department recommends that the indoor air quality be conducted to all residents. And that's, once again, it is to empower the residents to make their own judgment if concentration is higher than the screening level, if they believe that we should install a mitigation measure, and also to us to have a better understanding about the lateral distribution of the soil gas, and we can associate with the indoor air quality. The participation, it is on voluntary basis. You contact us if you want your home to be tested, and we will contact our contractor to set up an appointment. And you receive the data by email. And the department, it is placing all this information on our public repository, but for confidentiality, all the communication that we have, so all the written communication, we don't refer to the residence by itself. We call as unit, which is not associated with address. And any information that might identify the address or the name of the resident, any personal information, when we put it on a public repository, we redact it. So basically, we just put a black line to prevent that people might get those private information. This is a picture that shows a typical indoor air quality sample setup. It's we go to your property, and basically we drop it off. We call this as a summa canister, and we open up the valve, and 24 hours later, we collect the sample. So the entire process is this. So first, you contact us that you are interested to collect an indoor sample from your home. Then we'll send to you some access agreement. You get that access agreement, and we send some fact sheets to explaining how the indoor air is collected. And also, it is highly recommended that at least 48 hours before the date that has scheduled to collect indoor air, you have to remove all the household materials that might have volatile organic compounds. So that's very important that you have removed all those household products from your house 48 hours before, because otherwise we might have detection of other chemicals that's not associated with the chemicals that we are investigating, or even so, some of the household products might have the same type of chemical that we are investigating. So therefore, if they are inside your home during the time that we're collecting the air sample, we will not be able to assess if what we're seeing in the air is coming from the ground or it's coming from the household products. Next slide, please. So this slide shows a summary of all the indoor residents that we collect and the dates that we did the indoor sampling. So we initiate the first indoor sampling was done in January, February 2012, and it was collected at the pool house in the community center. Between 2014 and 2015, we collect in the two events several residents. You see 45 and 35, but they don't add up. So we didn't collect from 80 residents because there are some replications. So those combined are 49 residents. So between 2014 and 2015, we collect from 49 residents. In 2016 to 2022, 23 residents. And at the time that I prepared this presentation, we collect from 1 residence. All combined, we sample 54 residents, which is about 28% of the 190 townhomes at the property. And can you return, please? And overall, I would like to express that the indoor results does not show a very good correlation with the soil gas data. So that implies that it's not always that we see high concentration in the soil gas means that the indoor quality has been impacted. So that's what's so important to us to collect the indoor air sample to confirm there is any risk or not. And also, as a resident has pointed out about the TCE, because the TCE has a very low concentration to us to be able to be protective. So for the accelerated response level and the urgent response level, it's very important to us to be protective to you, that you allow us to collect indoor samples. So therefore we can assess properly what is the concentration for the PCE and TCE. And if it is any mitigations needed, we will implemented. Next slide, please.
Mokes, we do have a question, and a very good question from Reverend Angela Brown. And I was just thinking the same thing. What household products contain the chemicals that you are looking for? So that'd be good to kind of give everyone an example of when they do the testing.
Okay, so I'm going to go straight to PC. I have found, although this is a not very, what I can say is, we have our environmental laws, which is a very restrictive for release of chemicals that we know that might pose health risk. But as a federal laws, our federal laws for household products are not as protective as the environmental laws. So that means that the industry is still using chemicals that is well known that pose health risk, such as PCE and TCE. So we know that some household products does contain PCE, such as glue. So if you see those glues, that's very good. That's we use, that's most likely they're fast to increase the adherence, and they're very resistant. Likely they have either PCE and TCE. One way you can sort it out is before you purchase any glue, you check the ingredients and see if they are listed trichloroethene or tetrachloroethene as part of the ingredients. And I do highly recommend myself as a citizen, do not buy those merchandise. But as a regulatory agency, we just advocate that you have to make your best judgment to decide which kind of household products you're going to buy and bring to your home. But for the indoor air sampling, as the regulatory agency, we know that there are products that contains VOC, and they might produce confounded chemicals that we're testing. We highly recommend those being removed. And finally, as I would like to say, that's the fact sheet that we send when, as part of the process to collect indoor sampling, we have a short list of chemicals or household products that might contain the VOCs.
And just speaking to the indoor air access agreement, again, if you send me an email, I can send you that form, and we'll get that processed as fast as we can and get that done. And if you have any neighbors that were not able to attend the meeting, maybe you could tell them about it, and we'll share the link as well when it's posted online so they can listen to the information, but let them know that it's no cost to do the indoor air sampling. And just send me an email and I will send you the form and we'll get the process started. And my apologies to the community members that had a delay or did not get tested when they want to. But, definitely do our best to remedy that, and we won't let that fall through the cracks as well. I don't see any questions. Are there any questions or hands that people have questions? I don't see any right now, so we can move forward.
Thank you. Now we're going to be talking about the last topic, which is the mitigation measures. For the mitigation measures, the indoor quality mitigation measures, it is required. The TSC, so how we define it is required or not, is basically we look at the indoor air concentration and we compare to our screening levels. If concentration is above the screening level, we will recommend the installation of mitigation measures. And the mitigation measure that we are considering at the Sandpiper property are the subslab deposition system, what we call in a more simplistic way, the fan system, and the coating material. This slide shows specifically the fan system. On the left-hand side, here's a schematic that shows how the fan system or the subslab it is installed. So we visit the site, we assess where is the the most likely areas that has vape intrusion. In that area, it is selected as the most suitable to install the subslab depressurization system. So we excavate from the external wall a ditch, and there we place perforated pipes, and that perforated pipes is connected to an exterior blower, which is going to create a vacuum. And that vacuum is going to create a negative pressure. Negative pressure means that whatever vapor that's in the soil, they want to go into the perforated pipe. But there is a limited radius of influence. And that radius of influence is based on the size of the blower and the size of the pipe and where we can excavate. So because we are installing this system in a house that's already being built, typically the radius influence is not as big as when you install the system when a house is being built. So we have to have that clear understanding that the department is promoting and installing mitigation measures to improve the indoor quality, but because the house is already being built, this mitigation system is not as efficient as if it is installed in a house that will be built. And outside, so we have the blower, we have placed the fence system inside an enclosure, and the intent of placing the enclosure is to contain any noise that might be emitted by the blower. And after we have installed the first time in 2014, some residents contact us indicating that the noise was too high, and we have improved it. We have placed some cushions and some other bears inside the enclosures. And based on our most recent measurements that we conduct during our maintenance of the system, we noticed that it has a very, I would say not sharp, but there is a good improvement of what was before and now. And when we measure the noise emission at 10 feet away from the enclosure, most of the time we're measuring the noise at levels of 49 to 45 decibels. As a comparison, 55 decibels is a typical noise on a normal conversation. And also I read that's a very quiet refrigerator that's supposed to emit 45 decibels. So it's supposed to be very quiet at 45 decibels. Next, please.
Mokes, we do have a couple of questions. We do have one question regarding the funding of the mitigation. Who pays for the mitigation costs? And I will say before Mokes answers, there is no cost to you for testing your indoor air. And I'll let Mokes give a fuller answer on the funding of the mitigation costs.
We have security funds to support all the indoor air sampling and all the mitigation measures that might be needed to be installed. For the ongoing operation maintenance of the installed mitigation systems, in a given time, the department will request additional funding to support. What I meant is we do not ask for infinite amount of funding, but we have funds already being placed that will be sufficient to conduct the indoor air sampling and also to install mitigation measures based on the number of systems that we anticipated to be installed if they are requested. And if we have a large amount of residents that we want to install their mitigations system for many reasons or collect indoor samples, we will request for additional fundings. And based on current scenario, it's very likely that we will be able to collect and secure the funding. So we are in a very good moment to be able to secure funds, to be able to continue our supplemental investigation, continues and support a volunteer indoor sampling at no cost, and installing mitigation measures.
Thank you, Mokes. That's great news about the funding. And I do have a question from Gail Randall. Can you repeat the name of the chemical that can be found in our household cleaning products?
Okay, we call volatile organic compounds. Those are not a chemical, that's categories that I mentioned at the very beginning. It is based on if those chemicals have a tendency to vaporize under normal temperature and atmospheric pressure. So there are VOCs. And VOC is a very long list of chemicals. And later on this presentation, I mentioned that there are a short list of VOCs that we're more concerned. And among of them, we are more concerned about the trichloroethene and the tetrachloroethene. So the PCE and TCE, but the household products can have an array of different chemicals that not listed on our chemical concerns, such as benzene, methylene chloride, and so on and so forth. If you allow us to collect indoor sample from your home, the department, it is assessing all the chemicals that are detectable based on the analytical method that has been chosen, and we compare to the screening levels, regardless of what kind of chemicals that we detected in the indoor air. And we identify if those chemicals that have been detected, they are more likely being associated to household products or from the ground or from ambient air. Just to give an example for ambient air, if you collect an indoor sample, you might see that we might correlate to a chemical called carbon tetrachloride, which is pervasive. So you see in ambient air, and you're going to see at indoor air, but they're not associated with household products, and they're not associated with the contamination or that is in the ground or in the groundwater.
Does that answer your question, Gail? Excellent. All right. Once again, thank you for these questions and helping us stay interactive and ensuring that everyone understands what we're talking about, because it's very technical, and Mokes is easily moves in between the technical and the I guess you would say the layman's terms better than I would. So thank you for these questions and helping us all ensure that we understand.
And I also like to make a comment on that. I understand these presentations, there is a lot of technical terms. There are a lot of reference to chemistry and other science. And we thought that providing this information on this virtual community meeting is a way to us to be able to convey our communication in a way that's more understandable to the community, which is ultimately our goal. We are an environmental agency we are trying to be transparent in our decisions, and we are always happy to share the knowledge that we acquired, and in a way that's always to empower ourselves and the community that we serve to enable us to accomplish our mission, which is to protect you. So it's very important to us to have this type of meeting and touch upon some of the technical aspects in a way to facilitate and improve our communication to you. So this is a slide that I place in a summary table that compares when the indoor air at certain residence, when we have our mitigation system, here is the fan system, it's installed, and when not installed. And then it has two columns that show what's the human health screening level and the toxicity. And the toxicity that I place for TCE, it is 2, which is the first number, which is the accelerated response action level. And for the house that we did not have a fan system installed, the highest concentration that collect between 2019 2022, it was 1.6 except for one outlier, which was 20. And from that outlier, we already have installed a mitigation system that has reduced the concentration to lower the screening level. So having that in mind, what I want to stress for all the residents that we have installed a fan system, they are being effective to reduce TCE to concentration that does not pose health risk, which is an excellent news. For the PCE, not much so. And I'm going to explain why. So for the PCE, the highest concentration that we found from 2019 to 2022 was 1.9. But we have detected, as you see, that this PCE in some residents is still above 1.1. And if one outlier is 9.1, those are few units that's the fence is installed that has not reduced PCE concentration to either very just above or lower than the screen level. So for the 1.1 residents, we are in contact with the residents to try to determine if it is associated with household products. We will also investigate what it is the concentration of the soil vapor that's coming out from the fan system. We will also recommend us to install probes to find out what is actually the soil gas concentration beneath the slab. Because what we have seen is the PCE concentration that we are measuring on those residents that has installed the mitigation system does not correlate well with the soil gas data that we collect nearby. So long story short is, it's not always that even if we install a mitigation system in your home, such as a fan system, that we always going to have indoor air concentration lower the screening level. That's our goal. If it's not, we will look at the data. We're going to see if we can adjust the mitigation systems installed. And also, after we doing our adjustment, if the concentration is still, the indoor air is still showing that PC or TC is still above the screening level, we will continue our investigation to see what it is the cause that the indoor air is still above the screening level. But typically, the system has been efficient to reduce the PCE, TCE concentration to a safer level. Next slide, please.
Mokes. So we've got a couple of great questions. Earlier, you had spoke about, DTSC looking for a financially responsible party, and we have a question about who is financially responsible for the continuing VOC cleanup of the Sandpiper complex.
And we had a settlement with the Citation Homes way back in 1933. In that settlement, it was defined that was set up what would be the responsibility of them. And since then, we have determined that the site does not have a viable financial party, and we have a terminology for that. We call the site as an orphan site. So that implies that the state of California is the only viable party to be able to support and clean up the site. That's why the department is using state fundings, and that's why we're so diligent to look for opportunities to secure funds for this community, because we believe that this community has disproportionately been impacted by this contamination, because the site was developed after the law was promulgated, and that's why we think that we need to be diligent to trying to reduce the contamination to a level that does not pose health risk to the community.
I think you meant it was developed before the law was promulgated.
Correct. 2 years after.
Yeah, got it. And I have another question. How many homes in the Sandpiper have had a fan system installed so far?
I believe it's 9.
9 homes. Thank you, Mokes.
Welcome.
And it looks like that's all the questions we have right now. Thank you for those questions.
Okay, so this is the second mitigation measure. This is, we did a pilot study in a unit. We call residences unit. And I don't know if it is part of this community meeting, but I really appreciate the opportunity that they have allowed us to conduct this pilot study. It was on a very special occasion. Was done before I start managing the site when this residence was selected. But it was a very good opportunity because the proper owners was remodeling the property. And so it was the very good time to run this pilot test. And the pilot test was very positive because we have before detect PCE and TCE at concentration above the screen level. And when we complete the pilot study in 2019, we have not seen PCE and TCE in a concentration above the screen level. And when we did another testing in 2022, the indoor quality was still safe. So it means that the PCE and TCE concentration was lower than screening level. Next slide, please. So this is how actually we do the coating material application. So that's why we typically initially advocate the mitigation measure as a fan system, because for applying the coating material, it is much more invasive. In a way, there is a much more work because we need to expose the entire flooring. So it means that the entire ground flooring, first floor of your residence, you need to be exposed. So all the furniture need to be moved. So basically, this is more suitable in a situation that's when the flooring is going to be changed. There'll be a very good time to contact us. So initially, we do the slab preparation, which is abrasion. And after, as in this property, as you can see, there is a lot of cracking there. So the second stage, it is sealing the cracks in the penetration. Then we apply what they call a prime, which is the sign surface. And finally, the last stage, we apply the coating material. And then as an option, after applying the coating material, you can pick different colors. They have different colors. And also you can place tiles or other tiling material or cover material on top of the coating material, but there are some caveats on there. So first, the coating material is efficient as long as it is intact. So it means that if you have any scratching or abrasion of the coating material, they will lose efficiency. And second, if it is any cracking, like if it is on the foundation or the concrete on slab grade foundation has any movement or settlement, it might have some cracking. This cracking might crack the coating and then it loses its efficiency. And that's one of the reasons that typically when you apply those coating materials, they recommend that the surface of the coating material must be visible because then it's easier to be maintained. But this is an option to the residents. They might decide to apply this when they're remodeling. They might decide to keep the application material as is, but aesthetically, they might decide to place tiles or linoleum on the cover, but then will not be able to assess how the coating material, if it is effective or not. The only way we would find out if it is later, we collect indoor samples and we can assess how it is indoor quality. Next, please. I think this is when we open up for the general question or any specific questions.
Thank you, folks.
Welcome.
Thank you for that very informative presentation. We're now going to open it up to the community for any questions. And as before, on the next slide, I'll show the instructions, and we ask that if you are speaking, to just be mindful of giving your other community members time to speak. But we are definitely open to any questions or comments that you may have. Next slide, please. And this is just the instructions again, just going over. If you want to ask your question, just click on the raise hand icon, and you can ask you to unmute, or you can type your question in the Q&A. So definitely looking forward to any questions or comments that you might have. I do have a question in the Q&A. Did the heavy rains we had this winter help to remove some of the contamination?
I'm thinking here. So if the groundwater means on the property, right? So for looking for that, we need to consider how much was the rain event at nearby the property, and the change of the groundwater elevation, the flow of the velocity, the velocity of the groundwater flow. To have a meaningful change on the velocity, you need to have a very abrupt change of the groundwater elevation, and based on our measurements that we collect from the groundwater monitoring wells, we have not seen some meaningful change on the groundwater elevation. So I would say that because of that, unlikely that we might see higher groundwater flow in the property area, and also the change on the groundwater on the concentration is more dependable on the chemical equilibrium between where the contamination are located. If it is more so in a porous media or in a more fine material, that has more, I would say, way to control how the contamination might migrate into the groundwater and mobilize and migrate downwards.
Thank you, Mokes. And then I've got another question here, looking for just a little more clarity on your previous answer. Please restate your answer. Was the settlement with Citation Homes prior to Sandpiper construction? And then secondly, is there a dollar amount attached to that settlement?
My understanding is that the property was purchased in 1977, and the property was developed between 1977 and 78. Perhaps that's the number. And the settlement number, top of my mind, I think was $6 million. But I'll be happy to confirm those numbers with you.
Thank you, Mokes. I'll make a quick note of that as one of the.
And I also like to mention all that settlement money was for the site, paying for the site categorization and the installation of the groundwater remedy, and the 14 years that the system was run, and all the groundwater monitoring associated with that, part of the pilot study. So all that money was used for that.
Thank you.
And another point I want to make is the settlement money was defined based on the assumption that at that time, the understanding was that the impact of the contamination was only in the groundwater. The department learned with better understanding with the science and the results that those chemicals, the TCE, PCE, also would pose vapor intrusion risk based on the new screening levels and the toxicity that was uncovered and understood after the department has selected the remedy, after the department has determined that the contamination was only need to be cleaned up and remediate only the groundwater. That's one of the reasons why the settlement funded was $6 million, and it was mostly used for the groundwater remedy.
Thank you. Thank you for the clarity. I have a question from Brandon. Are there any known health complications attributable to the contamination of this site? What kind of health complications could arise from the contamination?
Well, first I want to put a caveat. Who am I? I am a professional geologist, and I do have a PhD in civil engineer. I'm not a physician, and I'm not a toxicologist, so this is not my expertise. But we have very good reference material that I'll be happy to share that has been produced by some public agency that does list the TCE and PCE health effects, and also for other chemicals, and we'll be happy to share those material to you.
Thank you, Mokes. I'll make a quick note of that. And then we have a question here from Dapadaka. As we understand these chemicals better, some of the exposure limits are reduced over time, like for PFAS. For example, how have permissible exposure limits changed with these chemicals over time, and what is the trend toward these chemicals in particular?
Okay, so you have used the PFAS as an example. I'm not going to talk specifically about PFAS because PFAS is not being part of our investigation. It'll be more my answer will be more tailored to. I'm going to refer to PC and TC. So the screen levels that I have pointed out one of the slides, it is based on scientific knowledge, understanding. So those screen levels is based on scientific studies, research, and after have some common understanding about risk based on laboratory studies using, at the time, mammals to correlate to humans, they would define what would be a likely concentration that might pose some health effects, and then has a lot of conservative assessments and such as how long you're going to be exposed, what's likely the concentration, and then it's defined what would be the screen level. And those screen levels can change based on the scientific understanding, which change over time. Now I want to go to the PFAS, because PFAS, it is a very new, evolving concern, and the science is not there yet. So I think this is a very good example that at this moment, either the federal or the state environmental protective agency, so in this case, the EPA or the California EPA, we have not yet set up a maximum contaminant level for drinkable water for PFAS, but will be. I read today that by the end of the year, the federal EPA will promulgate PFAS as part of the MCL, and that has a lot of repercussions. And all the environmental agency and the water purveyors that they need to ensure that the PFAS need to be lower than the MCL. So it is evolving and changing over time. And the main goal, it is always to be protective based on the current understanding of the science. So it is scientific based knowledge.
Thank you, Mokes. We have another great question. I believe in slide 20, you spoke about the treatment system being shut down. The question is, when the treatment system was shut down, why was it attributed to the system no longer working as opposed to reduction in toxic levels?
A very good point. We have shut down the system because it was not removing enough amount of contamination, and based on the projection of if the system was running, would not reach the level that we protected. So basically, we will continue running the system. We will remove minimum amount of mass of the contamination, and we will not reach the remediation goal. And that was the main reason why we shut down, because we thought it was not being protective. It was spending state funding money, and also was not, it was emitting a lot of CO2 in a way because it was impacting the climate, and we thought it was not beneficial. And it was more beneficial using the state fundings for alternative remedies that would be more efficient to reduce the contamination present in the groundwater. And that's why we run some pilot studies. And of the pilot study, we have identified that what we call in situ means that we place in the local, in the area, bioremediation, which is we inject, that's why in situ, and into the well, food grade material to the microorganism that lives on the soil in the groundwater, and they can use the contamination to thrive. And as a side effect, because they use the contamination to thrive, either as a food or to breathe, because some microorganisms use PCE and TCE to breathe instead of using oxygen as us. They use TCE and PCE. And in that process, they, through their metabolic process, they reduce the concentration of the contamination. And that's a remedy that we're considering and likely that we're going to be selecting. And when we go into the public comment for our remedial action plan, which we're going to be sharing with the community, what we think that's the appropriate remedy with more information and the locations where we're going to be injecting. And likely will be the in situ bioremediation.
Thank you, Mokes. And that answer was pretty technical. Did that answer your question? Was that understandable, I guess, to lack of a better way of saying it? But did that answer your question? And I didn't get a name of the person. Excellent. Thank you so much. That did answer the question.
Oh, thank you. Otherwise, I could explain a different way.
Okay, let's see if we have any more questions. And thank you. These are great questions and amazing questions that were being asked. Okay, here we go. Are the contamination levels in the Sandpiper anywhere near those that caused the closure of McClymonds High in Oakland in the past year or so? And weren't the same chemicals involved?
I was not the project manager of that site in Oakland, but I know it was about vape intrusion, and I know it was about volatile organic compounds, but I do not know if it was specifically PC and TC. But if it is managed by our department, we follow the same guidance and we follow the same process. So basically, I would say that we collect indoor samples and we compare to the screening levels. If concentration is above the screening levels, we will recommend to install mitigation measures, and we will continue our investigation to determine the source and propose a remedy. So I would say, because it is volatile organic compounds, likely PC and TC, it's likely to be the same type of chemicals. But I do apologize because the site that you're referring, I'm not a project manager, so therefore I don't have all the detailed information top of my mind. Apologize for that.
We have another question here. What is the approximate size of the treatment structure you propose for the new pilot program?
So this is So the pilot study that we're proposing on the Cornwall area between Croydon and Dundee Court, they will consist of a generator, because we need to have power source, and a mobile self-contained blower. So I have contact with our vendors, and they have indicated that's the size that they are anticipating that might be suitable to install at the Sandpiper. But it's very important to us to know if that size will be efficient, and to get what we call the radius of influence, so be able to remove a lot of contamination, and how much will be the noise. Because I think, for my understanding, the noise, it is a very important issue and a concern to the community, and we like to promote and advocate a remedy that's not going to pose annoyance to the residents. So we want to be protective, but also we understand that we are in a residential community that's heavily developed. And we understand that if we install a system, it might be in someone's backyard. So we're very aware about that. And we are very concerned about this issue. And whatever we're going to be proposing, we like to propose the one that will emit the least amount of noise.
Thank you, Mokes. And I believe we did, to kind of piggyback on that question, we did talk about placement and like any obstructions. Did you want to maybe say a kind of a word about that?
I'm sorry?
About just blocking driveways or streets.
I mean, for the soil vapor, yes. Can you go back to the slide that shows the proposed location, which is?
Is that 36? Or 35?
No, before that, it is the there you go. So yeah, we choose this area because it is, as you know, as a community member, you are very familiar with the Sandpiper way better than me. So you know, we have two areas that has that's wide enough. One is next to the pool house, and this one we did the previous pilot study we did in 2012 in the area of the pool house. And the reason why we choose this, because we don't want to replicate the same type of pilot study in the same area, because we're going to get results that's similar. We would like to get in a different area because we want to know if we run the pilot study in a different area, how different would be, because we'll be proposing to solve the system, not only one location, but another location. So first it is why we choose in this location, because it's wide enough that we're not going to be blocking the traffic. Because if you choose, for instance, just to give an example here in Dundee Court, we will be blocking access to the residents, and we don't want to do that. Second, because we have now a very good understanding of the underground utility, so the location is to avoid a line of the underground utility. And third, it is that we know this location has, based on the soil vapor wells that we install nearby, has relatively high concentration of PCE. So if we, during the time that we're going to be running the pilot study, also we're going to be removing part of the contamination. So we think this is positive. So it's better to run the pilot study where we know the contamination is present. And also it's better to run the pilot study in an area that we know that we're going to be pose the minimal disturbance to the residents. But I don't know, if we have here, perhaps some are part of the audience, it is exactly residents that are going to be immediately impacted by this pilot study. We will contact you individually, and we will coordinate with you the field work, and we want to make sure that the field work activities that we're planning will not impede to you to go to your home. So we'll do it in this level, in this detail, when we going to implement the field work to minimize any disturbance to the residents that will be immediately impacted.
Thank you, Mo. It's very important to know, especially for the community members that are immediately impacted by that work there. Any other questions that anyone might have? We do have a question here related to the pilot study. How long will the pilot run? Won't the generator cause a lot of noise? And if so, how do you differentiate between the two pieces creating noise in this study?
Very good point. For the generator, my understanding, we are running off-site to get that number. So and also it is something that's our vendors, you will sort it out the different piece of equipment that consists this pilot study to assess actually how much is the noise only from or the system by itself. There is no, my understanding, there is no way to us to circumvent the usage of the generator because we don't have a power source capable to run the system. Eventually, when we actually install the system, if it is the case, would have the power system properly installed. Time frame, we already have engaged with the Dundee Homeowner Association, and we have indicated a time frame. We are envisioning that with support of the community that we will be allowed to initiate a pilot study with the background noise assessment at the first week of the 2 first weeks of August. And then we're going to be marking the location. We're going to be doing another utility survey because it's required. Although we have a very good resolution, we still have to require the external providers to do the marking. We have committed with the Home Association that we're going to be power washing the marking afterwards because we don't want to leave the site full of marks. So after that, we are planning to initiate the actual field work drilling on the last week of August to install in the wells, the extraction wells and the wells. That will be for about 5 days. And then later we come to collect the soil gas that will consist for 2 days. And in mid of September, we will run the pilot test for 5 days. And they'll be run from 8 to 5. At this point, I cannot tell you if it's going to be running consistently from 8 to 5. It will depend on the results, but the idea is that we're going to come to the site before 8 a.m. We're going to have our safety meeting. We call it the tailing gate. And then we're going to start doing the activities that might, cause noise, produce noise, only from 8 to 5. And the pilot study is going to run for 5 days.
Thank you, Mokes. And we have a question here. The remediation process, has been going on for over a decade now. Do you have a sense of what % of the contamination has been mitigated and what the future expectation to bring down the community exposures to below action levels, or is this unknowable?
Yeah, so that question was voiced to me before. There are many factors why it took so long. First is the nature of the contamination, because it does interact with the type of soil that's there. So that's a problem that's very challenging. Is not only to this property, but we see this across the South Bay because we have a lot of release of this type of chemicals and the type of geology is similar. So we have layers of coarse and fine material. The contamination first migrates to the more sand material and then resides on the more fine material. And then it's really hard to remove. We initiated with the groundwater extraction system. It was efficient to remove what we call the more mobile phase. So we remove 260 pounds or so of contamination. But after that, if you're just using like we call pump and treat, we're just pumping the groundwater from the ground and treat above the ground, it was not efficient. We shut down. And that was the reason why it was that delay. So we run for 10 years and it was not efficient. And from 2015 to now, which is about 8 years, we have not installed a initiative remedy. First, it was because of fundings. You didn't have security funds now. And then we had the 2 years of pandemic. I don't want to use that excuse, but it was adding 2 years. And that has posed some delays. But I want to state that we are now in the final phase of collecting the data. We have security funds to be able to complete a sectorization. We have enough fundings to go to the point that we will have the remedial action plan and to be able to enable us to request additional funds needed to install the system and start running. So hopefully with that, we will reduce the concentration of the contamination in the soil vapor, and in the groundwater, and be more protective.
Excellent. Thank you. It's great to hear that we're in the final stages of gathering data. I want to thank everyone for spending almost 2.5 hours with us this evening out of your busy schedules. As we close the meeting, I just want to mention a couple of things. If we can go to slide 51. So I just want to pass along, if you want to take a screenshot or a picture of the screen, this is our contact information for any more questions that you might have. And also for, if you'd like to send me an email so I can send you back the indoor air testing agreement, indoor access for testing for indoor air. We would love to get more samples to get more data, always wanting more data to be more protective and to have better solutions and to protect the community. So take a screenshot of our information. For those of you that may be on the phone, I'll just kind of read it out loud. Mokes Carvalho, project manager, phone number is 510-540-3757, or Moises Carvalho at dtsc.ca.gov, moises.carvalho at dtsc.gov. Or you can also reach out to me, and I can definitely get you set up with the indoor air testing at no cost to you again. And that's James Gambrell, and that's 510-529-7199. You can contact me by calling me or sending me an email, which is probably the most efficient way, because I can email you the form. You can fill it out and email it back or mail it back to me, your choice. But that's james.gambrell at dtsc.ca.gov, james.gambrell at dtsc.ca.gov. Again, thank you so much for joining us. And if we can go to the final screen there, the final slide. And so there's a lot of information that has been shared, and at the once we get the video uploaded to the YouTube site for DTSC, we could send that link out. But we also have some information repositories. So located in Berkeley, if you'd like to see a hard copy of any information, you can set up an appointment at the Department of Toxic Substances Control File Room at 700 Hines Avenue in Berkeley. 94710. And you can call to make an appointment, 510-540-3800. And also there's the DTSC database. So you can take a picture, a screenshot of the slides of the screen there, and you can go to the EnviroStore database at https://www.envirostore.dtsc.ca.gov. You'll search for Singer Friden, or you can enter the site code, which is 01360094. And once again, thank you for all your questions, and thank you so much for joining us tonight and giving us about 2.5 hours of your very, very valuable time. If you have any more questions, please reach out to us and let your neighbors know if they would like the free indoor air testing, because that's something that will really, really help the community and give Mokes the data that he needs to be more protective of the Sandpiper Townhome complex. And this concludes tonight's meeting. And again, thank you. And we wish everyone to have a great evening and stay safe. Thank you very much.